Those aren't Dyson spheres, they're hotDOGs. The best gravitational lens in the universe. New Starlinks are really bright in the radio, and SpaceX recovers its SuperHeavy. All this and more in this week's Space Bites. So what does the future of humanity look like? We don't know. But if you chart the use of energy throughout the entire history of humanity for hundreds of thousands of years, it is this smooth, exponential curve that just goes up and up and up. And each time when it thinks, okay, no, that's it, no one will need to use any more energy, we figure out a way to use more energy. Like right now, people are thinking about giant data centers for AI that are going to be using nuclear power plants and so on. And so the need for energy just continues to grow. And if you chart that into the future, then within a few hundred years, humanity will be using all of the energy that falls upon planet Earth. And if you chart it a few thousand years into the future, then humanity will use all of the energy that is being emitted by the sun. And so we know that idea as a Dyson sphere or a Dyson swarm, where you essentially enclose your star in some kind of sort of cloud of solar harvesting satellites, and you harvest all the energy coming from your star and use it for whatever. ChatGPT 5, who knows, running Crisis 3. And so if this is a possible logical future for humanity, astronomers have thought, could we look for these around other stars? And when you enclose an entire star in a sphere of satellites, then you're going to create a very strange signal. You're going to have something that looks like a star, but it's emitting in the infrared spectrum. And so astronomers have looked for this. And in a recent paper, astronomers said they had found about 7 candidate objects that they thought could be Dyson spheres. Now they were, they gave all the caveats. There's lots of other ways to explain them. And one of the big caveats that came along very shortly after that is that astronomers said there's a kind of object, a kind of quasar, that where you've got this actively feeding supermassive black hole that's surrounded by this cloud of gas and dust that obscures the direct light coming from it. And it creates this giant blobby signature in the infrared. And these are known as hot dust obscured galaxies, or hotDOGs. So people immediately said, okay, what you found could be Dyson spheres, but it might also be this very well-known thing called a hotDOG. And so now a new paper has come out where scientists have calculated what are the chances that they're not Dyson spheres, that they are actually hotDOGs. And when you consider that the number of quasars that are hotDOGs, about 1 in 3,000. And when you sort of calculate the total area of the sky and the number of these things that should be out there, then the numbers roughly nicely match up, that if you think you found 7 Dyson spheres, you have probably found 7 dust obscured galaxies. Although it would be really cool if we did find evidence of a Dyson sphere, we have to be careful and assume that it is a more natural, logical object instead of a giant technological sphere created by an advanced civilization. Now, I'm going to give you some homework about this at the end of this episode, so stick around for that. The best gravitational lens in the universe. Gravitational lenses are exceedingly rare. There really aren't a lot that have been found so far, and they are incredibly useful because you get this galaxy cluster that acts as a natural telescope lens for some background object. All of the galaxies, all of the dark matter, all of the gas concentrates the light like a natural telescope lens. And each one is precious and can tell us a lot of stuff. Well, astronomers have found the best gravitational lens that they've ever seen. Now, it's called the carousel lens. And what it seems to be is a foreground galaxy cluster that is about 5 billion light years away. And it is lensing 7 additional galaxies that are all lined up behind this foreground object. They're as close as 7.62 billion light years away, and they're as far as about 12 billion light years away. And not only that, but this lens contains an Einstein ring. It contains arcs and diamond-shaped lensing. One object has been lensed multiple times. And so I really, want to say that this is an absolute unit of a gravitational lens, and astronomers are going to be studying this for decades to come. The new Starlinks are a problem for radio astronomy. So people are very concerned about light pollution, and for good reason. I mean, As I mentioned in last week's video, humanity has already lost the Milky Way. 60% of people live in light polluted skies where they can't see the Milky Way. 80% of people in the US and in Europe can't see the Milky Way because of light pollution. And people are worried that these new satellite mega constellations are going to increase that light pollution. And they will, they do. There is some overall light pollution that comes from just the reflection of these satellites up there in space. Observatories like Vera Rubin and the ones that are searching for near-Earth asteroids can have satellite trails going through their images that can degrade the quality of their work. But just in general, when you walk outside and you look up, you don't see all of those satellites all of the time. And that's because they're fainter than what the human eye can see, especially if you live in one of those light polluted places that I mentioned. But there is another problem, another kind of light pollution that the Starlinks and other satellites are giving off, and that is in the radio. And when you think about it, visible light is a photon, radio waves are a photon, and so really it's still light pollution. Researchers measured the amount of leaked radio that is coming off of the second generation of Starlinks, the Gen 2. And these are like a little bigger, a little more powerful, and they leak about 32 times more radio waves than the previous generation. And when you think about some of the most sensitive radio telescopes on Earth, things like the LOFAR instrument in the Netherlands, the upcoming Square Kilometre Array, Meerkat in South Africa, that these see the Starlinks about 10 million times brighter than the kinds of really faint galaxies that they're trying to observe. And the problem is that these Starlinks are passing overhead and they don't go into the Earth's shadow. They just continue to leak their radiation as they pass overhead. And so I think a lot of people are sleeping on the real light pollution problem: radio waves. And this is an intermediate generation. There's going to be an even bigger version that's going to be launched with Starship, which is probably going to leak even more radiation. So hopefully people can come to some kind of resolution and try to minimize the amount of light pollution, radio pollution that is coming off of these Starlinks. Speaking of Starship, after the IFT-4 flight happened and SpaceX had the SuperHeavy land gently in the Gulf of Mexico and then sink underneath the waves, a lot of people asked, are they going to try to recover this rocket? And so based on my reporting, I hadn't heard anyone that had plans to try and recover this rocket from the bottom of the Gulf of Mexico. Well, apparently they did have plans. And this week, Elon Musk shared pictures of them pulling the SuperHeavy out of the Gulf of Mexico. He described it as a fixer-upper, but obviously it's not going to get reused, but it is really important for them to be able to look into it, diagnose any of the issues that they had with it. They've got the actual hardware there that they can examine it. It would be even better if they could get their hands on the upper stage of the Starship, which ditched in the Indian Ocean, but it's in much deeper water. So that is going to be a tall order, but maybe there are plans to do that too. A zebra stone on Mars. Well, look at what Perseverance found, a rock, a really fancy rock on Mars. So the rover team at NASA was driving the Perseverance rover when off on the horizon, they saw this tiny object that they thought needed a closer look. They had Perseverance drive over and get closer and closer, and they found this really cool rock that's covered in these sort of black and white zebra stripes. The rock itself is about 10 centimeters across, and it's unlike anything that is in the surroundings. And so scientists think that it probably eroded from an area that is farther uphill and then rolled down the slope to arrive at this location. And geologists are still trying to figure out exactly what kind of a rock that it is, but it's like some kind of combination of igneous and metamorphic process. I have rocks here which we know have gone through some level of metamorphic process to look something like this. Hopefully at some point we'll find out exactly what this rock is, but it's one of the coolest rocks that I think have been found on Mars so far. Every week we do a vote on our channel where you tell us what you thought was the best story of the week. And the winner this week was a concept mission to fly to Neptune. Clearly there is huge demand for a mission to Neptune. So thank you everybody who voted this week. Now we post the new vote on the channel within about 24 hours of when we release Space Bites. So you can go to the community tab to find it, or you're just scrolling on your phone and the vote comes up. Just take a second and give us a vote. And if you want to sort of train YouTube, make sure you're subscribed, make sure that you like a bunch of our videos and watch a bunch of others, vote whenever you see the votes, and then they'll just show up in your feed every week. How a nearby supernova left its mark on Earth life. When a massive star runs out of fuel in its core, it can detonate as a supernova. And it's believed that these detonating supernovae can provide some of the heavier elements that we find here on Earth. We also get them from just dying regular stars. We get them from kilonova. We get them from the Big Bang nucleosynthesis, but supernova are another source. And geologists have gone and looked at ocean sediment layers and realized that there are sediment layers that are heavy in iron-60. And this is the kind of metal that is produced in a supernova explosion. And so when they trace back the layers, they figure out that one supernova probably hit Earth about 2 million years ago, and then another hit the Earth about 6 million years ago. But the story's a little more complicated than that. The solar system is located in a larger structure called the local bubble. And this is a region where astronomers think that a whole bunch of supernovae went off over some period of time and pushed out a lot of interstellar material and created this sort of bubble that surrounds the solar system and other nearby stars. And at some point in the past 5 million years or so, the sun entered the local bubble. And when it did, the iron-60 from that 6 million year old supernova rained down on planet Earth. But then that other one that happened about 2 million years ago, that happened and hit us directly. And so one of the big questions that scientists have is, what is the effect to life on Earth when a supernova goes off nearby? They calculated the kind of effect if you have this radioactive material that is falling down to Earth across the entire planet. And what they found is you get increased amounts of DNA damage. In addition to that causing animals to die, it probably also accelerated evolution. It caused a greater species diversification. So it could very well be that some of the big jumps that we have in the evolution of life on Earth were due to a nearby supernova going off and increasing the amount of radiation on the planet and giving life an encouragement to adapt. 2 Chinese rocket hops. While we've been seeing the advances of reusable rocketry from SpaceX, several Chinese companies are working on their own versions of reusable rockets. So we had a couple of successful tests within the last couple of weeks that I wanted to talk about. So the first one we're going to look at comes from a company called Landspace, and they did a test of their Zhuche 3 rocket. We saw a test earlier this year in January, and this time they flew the rocket to an altitude of 10 kilometers, and they did a secondary ignition test. They turned off the engine at around the 119-second mark, did a glide for a little while, and then turned the engine back on and were able to land safely.
Hello, IT. Have you tried turning it off and on again?
So now they've hit 10 kilometers, and so they're moving towards a full orbital flight, probably by 2025. Second up is a company called Deep Blue Aerospace, and they tested their rocket called Nebula 1. And same thing, this is a hop test where the rocket went up to an altitude of about 5 kilometers and then came back down and was just about to land when it exploded. And what I think is really amazing about this is that the company behind this, Deep Blue Aerospace, they shared a statement almost immediately after the failure. They shared this incredible high resolution image and video from drones showing in super slow-mo as their rocket tore itself apart moments from successfully landing. They explained what they think went wrong. It was a surprising amount of transparency from a company out of China. And I think like this is fine. Like if China, if you're watching this, this is good. This is what you want to do. You want to just show all of the problems, all of the issues, but also all of the successes, and just make this process transparent so folks in the West can see what you're up to. And we know that sometimes it's going to go badly and other times it's going to be successful, but this allows us to report on the news that's happening. So congratulations on the spectacular failure by everybody at Deep Blue Aerospace. While you're watching this week's Space Bites, I am writing my weekly email newsletter, The Guide to Space. And this is where I give you stories that you're not going to see here or pretty much anywhere else. For example, a new catalog that charts the evolution of the universe over time, how advanced civilizations will overheat their planets within 1,000 years, and shape-shifting robots that mimic muscle movements. I write my newsletter every Friday. It goes out to 72,000 of my closest friends. It's completely free. There's no advertisements. So if you want to sign up, go to universetoday.com/newsletter. Now I want to give you some Dyson Sphere homework, but first I'd like to thank our patrons. Thanks to Abe Kingston, Adam Schaefer, Barry Lake Roofing, David Gilton, David Matz, Dennis Alberti, Dustin Cable, Jeremy Matter, Jim Burke, Jordan Young, Josh Schultz, Paul Robach, ScienceWorldRecord.org, SpiderSwap.io, Stephen Krasaki, Stephen Fowler Munley, and Vlad Shiplin, who support us at the Master of the Universe level, and all of our other supporters on Patreon. So a lot of people say that when you build a Dyson Sphere, an advanced enough civilization should be able to hide the heat coming from the Dyson Sphere. And so if you imagine you enclose your star in a sphere that is now not emanating any heat, any radiation out into space, you have created an oven. And so you're just going to heat up and heat up and heat up. And at some point you've got to release that heat. The laws of thermodynamics demand it. So here's your homework question. If you wanted to hide your Dyson Sphere, you would have to make it very large. You would have to make the Dyson Sphere so big that it is then releasing waste heat at just a couple of degrees above absolute zero. So that if somebody is doing a survey of the sky, they're not going to notice your giant blob that is 4 Kelvin as opposed to 2 Kelvin for the background temperature of the universe. And so the question is, how big a Dyson Sphere would you have to make around a star like the sun so that the temperature, the infrared temperature coming off of that Dyson Sphere is only 2 degrees above the background temperature of the universe? All right, so put your answers in the comments down below. It'd be interesting to see sort of the discussion that comes from that. All right, we'll see you next week.